Okay, welcome back. In my last lecture on Module 5, I got sort of cut off in the middle of the asbestos problem. So I'm just going to do a mini lecture on just the asbestos problem before we continue and start on combustion analysis. So let me share the screen and we can go over this problem. This problem is a little bit harder, so I wanted to make sure that everybody was on the same page with understanding how to do this. So let's look at this problem. So asbestos was used for years as an insulating material in buildings until prolonged exposure to asbestos was demonstrated to cause lung cancer. Asbestos is a mineral containing magnesium, silicon, oxygen, and hydrogen. One form of asbestos, which is called chrysotile, this is the molar mass, which is 520.27 grams per mole, has the composition, the percent composition, 28.03% magnesium, 21.60% silicon, and 1.16% hydrogen. If you noticed, they only gave me percentages for 3 elements. They did not give me the percentage for oxygen. You have to be very careful to make sure that you need to make sure these percentages add up to 100%, or that if it tells you it has a specific element in it and they don't give you data for it, you're going to have to figure out the data for that particular element. So what we know in this problem is that the 100% of all the elements is going to be a combination of the percentage from all the elements. So we know that if I have 28.03% magnesium and 21.60% silicon and 1.16% hydrogen, sum X is going to equal the percent oxygen. So I can use this equation in order to figure out the percentage of oxygen that I have in this material. So if I do that, if I take 100 minus 28.03 minus 21.60 minus 1.16, what I'm going to get is 49.21% oxygen. So now I have the percent composition for the entire sample. So let's go and do what we were doing before. We want the molecular formula, but to get the molecular formula, we first need to determine the empirical formula. So now that I have my full percent compositions, what I'm going to do is use the procedure that we talked about to determine the empirical formula. If I have 28.03 grams of magnesium, because remember, I'm assuming we have 100 grams when I have percentages. And then for every 1 mole of magnesium, I have 24.31 grams of magnesium. So this is going to give me 1.1530 moles of magnesium. Let me use a different color. And what I also know is that I have 21.60 grams of silicon. I'm going to do the same thing. For every 1 mole of silicon, I have 28.09 grams of silicon. 21.60 divided by 28.09 gives me 0.76896 moles of silicon. The next element on my list is hydrogen. So if I do the same thing for hydrogen, for every 1 mole of H, I have 1.008 grams of H. 1.16 divided by 1.008. That gives me 1.5079 moles of hydrogen. And then the next guy is going to be my oxygen. I have 49.21 grams of oxygen. For every 1 mole of oxygen, I have 16.00 grams of oxygen. So that gives me 3.0756 moles of oxygen. So now I have my mole values. And remember, I'm going to take the one that is the smallest, and I'm going to divide everything by that smallest value. So I divide this one, 0.76896. This is going to be 1.499, which is 1.5. Remember, that ends in a 0.5, so that's not an integer. We're going to have to do something with that. This guy is just divided by itself, so that is going to equal to 1. This guy is divided by that, and that's going to be exactly 1.496, which is also 1.5. And then this, if I divide by 0.76896, I get 3.999, which is 4. So now all of these, right? This is an integer. This is an integer. But I have those two values that are 1.5. So I need to multiply everything by 2. So that gives me my empirical formula being magnesium 3, silicon 2, hydrogen 3, oxygen 8. So this is the empirical formula. So what do I have to do now? I have to find my value of N, which is going to be the molar mass divided by the mass of the empirical formula. I have to know if this is larger than 1, and if I have to multiply my empirical formula by any integer in order to get the molecular formula. So remember, back in the product, or in the problem, it said my molar mass was 520.27. Now, what is the mass of my empirical formula? I have 3 magnesiums, so I have 3 times 24.31, plus I have 2 silicons, so I have 2 times 28.09, plus I have 3 hydrogens, so that's 3 times 1.008, plus I have 8 oxygen. So that's 8 times 16. And what I get when I add this up is 260.134 grams per mole. So that's going to be the denominator here. And I'm going to multiply or divide this by 260.135. What I'm going to notice is my 520.27 divided by the mass of my molecular or my empirical formula gives me an integer value of 2. So my molecular formula is going to be equal to 2 times my empirical formula, which is equal to 2 times Mg3Si2H3O8. So that means I have magnesium 6, silicon 4, hydrogen 6, O16. And this is the molecular formula for that chrysolite. All right, this is the end for this little mini lecture on how to do this problem. Hopefully this all makes sense. And if you have any questions, make sure you get in contact with me. But other than that, the next lecture will be the next part of Module 5, which is going to be on combustion analysis. I'll see you later. Bye.